So you want to turn to in your packets, your Unit 7 packets that you got yesterday, turn to page 3. So what it says here is we are proving parallelograms in the coordinate plane. What that means is, I briefly touched on this yesterday, we're going to be able to look at a set of coordinate points and you can tell me whether or not they form a parallelogram or not. So in order to do this, we have to think about what it means to be a parallelogram. Remember, one of the things that we said, well, a couple of things that we said, and the way that we're going to use these coordinate points to do this is telling whether sides are parallel or if they are congruent with each other. So the first method that we have up there is proving both pairs of opposite sides are congruent. So what that means is, if I've got this here parallelogram, I want to say side AB is congruent to side DC. And I also want to say that side AD is congruent to BC. So what that looks like over here is AB and DC, AD and BC. If I can show that, I can say that ABCD is a parallelogram. In order to do this, this box over here says use something. You're using the distance formula to do that. Once I go through all these, we'll look at some examples. Second method says prove both pairs of opposite sides are parallel. So I'm saying the same thing. AB is parallel, well, not the same thing, but I'm using the same pairs of sides. AB is parallel to DC, and AD is parallel to BC. If I can show those two things, then I can say ABCD is a parallelogram. What I'm using in this case is the slope formula. Because remember, the easiest way for me to tell if two things are parallel is if I take the slope of the line that they form. They should have the same slope. So I'm going to use the slope formula for that one. Method 3 says prove one pair of opposite sides are congruent and parallel. So by that I mean I am saying that I want to say if AB is congruent to DC, and I can also say that AB is parallel to DC, then I can say that ABCD is a parallelogram. If I'm talking about congruence and parallelness, then I am talking about using both of those two formulas, the distance formula and the slope formula. Okay, let's see how this plays out. Let's look at number 1. If I've got number 1, it says determine whether the figure is a parallelogram using the distance formula. It says A is -7, 4, B is 1, 2, C is 9, -8, and D is 1, -6. So I'm going to do it like this. Granted, I'm pretty much drawing a parallelogram now, but we're going to actually prove whether or not that is the case. And I'm going to say this is A, B, C, D. Now, if you were to actually graph these points out, the parallelogram might look a little bit different than this, but that's okay. As long as we maintain this correct order, if I say A, B, C, D, that's how these parallelograms are read. I have to go clockwise like that. So I'm going to list out what I want to be true here. In order to prove this thing is a parallelogram, it says they want me to use the distance formula. So I'm looking for opposite sides to be congruent. So what I want is for AB to be congruent to DC, and I want AD to be congruent to BC. So basically, what you're doing, you want to find the distance use the distance formula to find how long each of those sides are. So let's go. So if I'm saying AB, remember my distance formula. Where can I write it? I'll write it up here. Distance equals x minus x squared plus y minus y squared. So we'll say x2 minus x1, y2 minus y1. Remember, order doesn't matter too much inside the distance formula. So if I'm looking at AB, I'm looking at these two right here. So if I'm finding that distance, I'll start with this. I'll start with 1. So I'm going to say 1 minus negative 7, that turns into a positive, squared, plus 2 minus 4 squared. And then I'm just plugging that, I'm doing that math. So when I do that math out, you're going to get AB equals the square root of 68. Okay, now I'm not going to go through it. I'm not going to waste your time to do the math for each and every one of these. Distance formula is something that you should already know how to do. So I'll just tell you, when I do the math out for each of these, so if I find the length of BC, I'm going to get the length of BC as radical 164. Then I want to, like I said, we're looking for the length of each of these sides. CD is going to equal radical 68, and AD is going to equal radical 164. Now don't even bother putting these into your calculator to figure out, well, what does radical 68 really mean? What does that actually equal? Because I've got right here, I said that I want AB to be congruent to DC and for AD to be congruent to BC. So let's see if I've got that. I have got AB as being radical 68 and DC. Remember, I can go either way with this. So I said CD here, I said DC up there. That is a little bit more confusing. I should have put CD. Those are the same thing. They're both radical 68, so I'm good there. And then I said I wanted BC equal to AD. Both of those are equal to radical 164. Those give me those two things that I wanted. So if it says determine whether the figure is a parallelogram using the distance formula, yes it is. So let's have you guys do, actually, let's flip to the next page. Flip to the next page. Go to page 4. So I'm doing the same thing here. I'm going to draw myself. They want me to determine whether the figure is a parallelogram using the slope formula. So I'm going to draw my parallelogram again. That's W, X, Y, Z. Remember my slope formula is M, that's my slope, y2 minus y1 over x2 minus x1. Okay? So remember we said in order to use the slope formula, I want to say that opposite sides are parallel to each other. So what I want Wx to be parallel to xy, and I want Wz to be parallel to, oops, my bad. This should be Wx parallel to zy, Wz parallel to xy. Okay, so let's do the slope of Wx first. So if I'm going to say, I'll say that that's y2. So I'll say negative 6 minus negative 4 over 1 minus negative 7. I do that math out. That's going to give me negative 2 over positive 8, or negative 1/4. So that's my slope for Wx. Once again, I am not going to go through and do all of those slopes for you, because that's something that we've done this year and you've done in previous years, so I'm not going to go through and waste your time with all of that math. If I go through and solve for the rest of these, I would find the slope of yz equals negative 1/4 as well. So those two are in fact parallel. That was one of the things I wanted. I wanted Wx parallel to zy. I've got that. But I still need this. I need Wz parallel to xy. When I do that slope, if I do the slope of Wz, that equals negative 1. If I do the slope of xy, that equals negative 7 over 4. Those are not parallel, so therefore this is not a parallelogram. Because it does not meet those characteristics that we talked about. So here's what I'm going to do. I'm going to tell you a problem. I want to see problem 5 done. And I'm going to give you a whole set of problems that I want to see done tomorrow. So I'll get you started on this one. It's saying determine whether the figure is a parallelogram using the distance and slope formulas. You're basically putting those last two things that we did and mashing them together. This is method 3 from page 3 of your notes, if you want to glance back at that. What you're saying is you want to say that the pair of opposite sides is both congruent and it is parallel to one another. So what you're doing, you need to say that this is true using the distance formula. Sorry about that. And you need to say this is true using the slope formula. If that's the case, then it's parallelogram. If it's not, then it's not. So that's one that I want to see done, but I'm going to keep going because I have one more little topic that I want to get to, and then I'll tell you what I want you to do. So turn now to page 7. So like I said before, or yesterday I think, in class, I said that we were going to talk about parallelograms, and then we were going to talk about different types of parallelograms. One type of parallelogram is a rectangle. Again, rectangle is a shape that we are relatively familiar with, but now we're actually kind of dissecting the different properties of it. One thing that we want to know about them, all of the properties of parallelograms that we talked about yesterday still hold. The opposite sides are congruent, opposite sides are parallel, opposite angles congruent, consecutive angles supplementary, diagonals bisect each other. That's all still true. That stuff still helps us. But we want to add 2 more things to this list, because this is what's going to specifically tell me this thing is not only a parallelogram, but it's a rectangle. So the first thing that I want to talk about is that all angles are right angles. Oops. All the angles are right angles. Which I think we already know. That's not really that new or interesting. The second thing that we know is that not only are do the diagonals bisect each other, the diagonals of a rectangle are congruent to one another, which some of you might already know that, some of you might not, either way. So We're going to do the same thing that we did yesterday with just parallelograms in general, and we are going to look at how this shakes out down here for if they give me a picture of a rectangle, how can I use these properties to find each of these different pieces of information. Some of them are still easy, like the parallelograms, just the general parallelogram was. My opposite sides are congruent, so I'm going to say this over here is 10, this down here is 24. And that is two of the answers that they're looking for. They want QR, we know that's 10. They want SR, I know that's 24. Where it gets a little bit trickier is if you look at that, it's not immediately apparent what SQ is. SQ is one of those diagonals. But remember, one of the things that they told me is that that's a right angle. What I have in there is a right triangle where I know two sides and I need to find the third one being that diagonal. I know we have a little bit of trouble recognizing this, and some of you think way too much about it, but all this is, it's just the Pythagorean theorem. I'm just going to say, okay, to find SQ, I need to say, okay, 10 squared plus 24 squared equals x squared. When I do that, all that math out, I'm going to get 676 equals x squared, x equals 26. So my SQ is 26. Now they're asking me about PR. Okay, PR is another one of the diagonals in that, it's the other diagonal in that rectangle. Number 2 up here said diagonals are congruent. So if one diagonal is 26, the other one is also 26. And then the last one there, it wants me to find QT. QT is this guy right here. Remember, that is part of a diagonal that has been bisected. And that's not because it's a rectangle, that's because it's a parallelogram. So if it's been bisected, if the whole diagonal is 26, part of the diagonal is 13. Or that half the diagonal is 13, I should say. Okay. Next up, I want to do just one more with you guys, because I think you'll get it after that. I am confident in you. In this picture, they gave me an angle. I'm dealing with angles, no sides in this one. I'm looking at number 3. Sorry. Number 3 is where I'm looking right now. First thing they want me to do is they want me to find angle MJK. Well, MJK is a whole one of those angles that make up a rectangle, which we know from properties of a rectangle that we saw up there, that that's equal to 90 degrees. Okay? Not that interesting. Now they want me to find MJL. MJL. Not that interesting again, because this is something that we've worked with quite a bit. If this is a right angle, those are complementary angles. If this piece over here is 27, the remaining piece of it is 63. Right here. So that's what MJL is. So that piece is 63. Now, all across this thing, there's a lot of the same stuff going on. Remember, if I've got parallel lines, think about my alternate interior angles that I have here. My alternate interior angles is this guy and this guy down here. So if this is 27, this is also 27. Sorry, that's hard to read. But then, so if that's 27, again, remember, all of these are right angles. So if that's 27, this piece up here is also 63. So that is the next angle they're asking me for. They're asking for JLK, which is this guy. which we just said is 63. And then if we keep going on there, like I said, a lot of this stuff is very similar throughout this whole triangle. Angle KML, which is this one right here, that angle is also going to be 27 degrees. And angle MNL, this one is a little bit different. That's this one. This picture's getting kind of ugly now. If I pull that out, that's just a triangle. So if I said this one's 27, this one's 27, this is MNL up here. So in order to find that, I need to say, okay, 180 minus 27, minus another 27, and what you'll get is 126. Okay, here's what I want to see from you. This is the end of the notes that you'll be doing today. And you should have over an hour left of class, so there's a lot of time for you to work on these things. I want to see you complete number 5. On the next page, on page 8, I want you to do the evens. So you should do 6, 8, 10, and 12. So that'll give you some practice with those. And then in addition to that, I want you to do some review with I want you to do some review on this stuff and some review on the quadrilateral or the parallelogram stuff. So I want you on page 5 and 6 do all the evens. And then on pages 9 and 10 also do the evens. So I will leave those directions for you, so in case if you weren't listening, imagine that. You'll have those, and I'll write them on the board as well, so they'll be up there. That is what I will be checking for on Wednesday. So get to work on that, work with each other, help each other out. Check your homework from last night with each other as well to see how you did on that, because I know we didn't get too far in class. So get to it.